Thanks, Dave. All right, thank you everybody for being here. I know it's always tough to be in the last spot between you and the food and the amazing party, so I hope we're going to make the best out of it. And today, I want to talk about, well, a specific thing in Debezium, which is snapshotting and backfilling your data. And I will touch on what it is and what this means and why you would want to use it. But I'm saying all that because this talk is a bit different from the talks I usually do. So usually I talk a lot about use cases, why you would want to use Debezium or change data capture, what is in it for you by using those tools. Whereas today, I'm kind of assuming you already bought into this idea. So I will just do a quick recap on what Debezium is and what it does. And then, I will touch on this notion of snapshotting and backfilling your data. And now, and by the way, I promise it's the only meme I'm going to have in my talks. I'm not a big meme person. But when I speak to, or when I talk to Debezium users in the community, they always come up those kinds of questions. So yes, it works great for us, but how can we go about changing our filter configuration? So let's say there's another table which we want to capture. How can we go about that? How can we backfill this table? How can we just re-snapshot one particular table? How can we pause and resume long-running snapshots of tables? All those kinds of questions, they came up again and again in the Debezium community. There used to be some answers to that, I would say, and I will touch on that a little bit. But really, there's a major improvement, I would say, which happened in Debezium, well, not too long ago, which is about incremental snapshots, and this is essentially what I would like to talk about in this talk. Before I'm going to kick off things, so who knows what Debezium actually is? So I mentioned it a few times. Okay, who would feel ready to explain to somebody else what it is? Okay, there's like a few brave ones. Okay, who is using Debezium in production? Those are the very brave ones. That's great. All right, perfect. Thank you so much. So half of you, I mean, everybody seems to know what it is. Half of you are using it in production, I should say. That's great. Cool. So in terms of the agenda, I will briefly go back a little bit to this notion of the classic traditional snapshotting, which we always had in Debezium, which existed, pretty much from day one of the project. But then I will touch a little bit on the shortcomings of that traditional approach, so as to motivate why we added this notion of incremental snapshotting and what is so cool about it. And, well, if the demo gods are with me, I will also do a demo to show you how this all works. Now, a few words about myself. I am a software engineer at a company called Decodable. We work on a fully managed stream processing platform based on Apache Flink, based on Debezium, tools like that. So if you don't want to deal with all the hassle of operating those kinds of things, this is what we can help you with. I used to be the project lead for Debezium while I was at Red Hat. There's a few of my former Red Hat colleagues down there, so this is great. So I guess this is how people know me. There's another tool I'm very proud about. This is KCCuttle. It's a command line client for Kafka Connect. So I'm also going to show this in the demo. All right, so let's get into it. And I mean, most of you raised their hands when I asked, do you know what Debezium is? So really, just briefly, it's about getting change events out of your operational database. So something like Postgres, MySQL, Oracle, SQL Server, MongoDB, you name it. You have your operational data there, transactional data, and now you would like to react to changes in this data. So whenever something gets created, like a new customer record gets inserted, purchase order record gets updated, another kind of record gets deleted, you would like to be notified about this change, about this event, and you would like to propagate this event to downstream consumers so that they can then take this data and make sense out of it. So you might want to use it for updating your data warehouse or your search index or your cache. You might want to use it for propagating data changes between microservices. Hans-Peter spoke about the outbox pattern earlier today. So there's tons of use cases, and again, that's what I'm usually talking about, but not today. So that's my part about use cases. Just briefly, it's log-based, right? So it goes to the transaction log of your database and extracts the changes from this append-only log structure and emits them to consumers via Apache Kafka, but also via other data streaming platforms like Kinesis, Google Cloud PubSub, and so on. So that's Debezium in a nutshell. I think we're all on the same page. Now, how does this notion of snapshotting fit into this? Well, having the transaction log as the canonical source for our data is great in and by itself because, well, whenever a transaction comes into the database, it will append an event to this transaction log. And this is our perfect source for getting the changes in their correct order and propagating them. So that's cool. But the problem is, well, you don't have the transaction logs from the beginning of time, typically, right? Because they consume lots of space on your database machine. So typically, the database itself uses those transaction logs for two purposes. A, for transaction recovery. So in case there is fault scenarios, you would want to use the transaction logs to get back to a consistent state of your data. And B, for replicating data between different nodes in a database cluster. And in a sense, Debezium could be considered like another client in such a clustered database. So, but once the database has figured out, well, I don't need those logs for those two purposes any longer, well, it will discard them, right? So you want to free up the space on your disk. Now, this means if you set up Debezium and your database has been running already quite some time, well, you won't be able to get the entire state of your data from the transaction logs. Instead, you would have to go to the table files, technically speaking, and getting the data from there. And this is exactly what this notion of snapshotting is about. So when you start a new connector instance, you have the option to let the connector scan all the existing tables, or I should say the tables you're interested in, and then once this snapshot has been completed, well, then the connector would start to stream the changes from the transaction log. In terms of how does this data look like? Well, it's a Debezium change event, as you can see it here on the right-hand side. So it's pretty much the same event as an insert event. So if a record was created, you would see like 99% the record would be the same. The only difference really is you have this op discriminator to the lower part of the structure. And in this case, it's R as in read. So this tells you, okay, this is actually a record which originates from a snapshot. But otherwise, it's pretty much like an insert record. And I would say one of the key things to keep in mind is that Debezium uses the same mechanism for propagating the data, no matter whether it originates from streaming data from the transaction log or from doing a snapshot. So there's no separate side channel for backfilling your data, which could also be an option, right? You could think about, well, I could just go to my database, scan for data using JDBC or whatever API I want to use, and then somehow, switch over to reading from the transaction log. Here, this all happens under the hood with one unified experience and communication channel. So I think that's pretty good. So now, how does this work? Well, the general idea is we need to capture the current position in the transaction log. So, transactions are appended. So we want to get hold of one specific position in this transaction log. So we memorize that offset 1, 2, 3. Then we do this scanning operation. So essentially, we would just run a select against all the tables we are interested in. And then we would continue, or we would start to read the transaction log from this very offset. So this gives us exactly the consistency guarantees we are after. We do a snapshot of the data at one well-defined point in time, and then we start to read the log from exactly this point in time. And when I say point in time, I really mean offset in the transaction log. Now, how you do this? Well, this depends on the specific database, and its quirks, I would say, or like specifics. So, for instance, in case of MySQL, Debezium needs to get hold of the schema of your table. So we need to query the metadata from the database. How do those tables look like? Because the events which we receive during the streaming phase, they're not self-descriptive. So if you get an event from the bin log, we cannot fully decide, okay, what are like column names, types, and so on. So you need to know the schema. So this means, in case of MySQL, this needs to happen like atomically. We need to make sure if we do this snapshot, and in particular the snapshot of the schema, that there may not be any schema changes happening at the same time. So for instance, the MySQL connector would take a very small, very short-lived log just to prevent any concurrent DDL changes while we do this schema snapshot. For a database like Postgres, it's a bit different. It doesn't really have to do this because it has a very excellent multi-version concurrency control implementation. So what that means is we essentially can start a transaction for reading data from the database at a specific offset. And this is what we see in the code snippet here. So for Postgres, Debezium uses what's called replication slots. So that's the mechanism for getting change events out of Postgres. And now what you can say when you create such a replication slot, so you give it a name and so on, you can say, I want to export this snapshot. So this happens with this export snapshot option. And this essentially gives back to you an offset in the transaction log. And now you can start a separate transaction or even multiple transactions at this very offset. So this is what we see here on the next line. So we can start our snapshotting transaction at this exact point when our replication slot was started. We can now scan all the tables we're curious about, and then we would actually begin to consume from this replication slot. So this means there's no locking involved here, and I even could parallelize this. So I could run multiple snapshot transactions for different tables or even different chunks of tables if I wanted to. Okay. So now, just briefly, and I realize a talk shouldn't be about like disseminating like reference implementation, which you could read up in the documentation and so on. But there's a few key options which I just wanted to mention briefly because I think you should just know about and be aware of them, and then you can read up about the specifics in the docs. So the first one, the first option which is relevant here is the snapshotting mode. So this tells the connector, okay, when should it actually do a snapshot? So you could tell it, okay, and I'm not specifying all the values here, by the way, I'm just listing a few ones. So I could say I want to do like this initial snapshot, and when I'm done with that, I'm never going to bother doing a snapshot again. Or I could say, I don't really care about the existing data in my database. I'm interested about the changes which are happening. So I could say never. Or I could say I want to do this recovery. And this comes back to what I mentioned about MySQL. We need there to get hold of the schema of the table structures. And actually also we need to persist this information. So the Debezium MySQL connector uses a specific schema history topic where it keeps track of the schema changes. And when it gets restarted, for instance, you have upgraded your connector to a new version, then it would read back this history topic so it knows what's the current status of the schema. And sometimes people just lose their history, their schema history topic, right? It happens maybe like wrong retention. I see some people nodding there. And then you want to recreate the schema history topic, and this is exactly what this recovery option is about. So that's about snapshotting modes, just briefly. Then another interesting one is, well, you can actually specify the contents of the data for your snapshot. So let's say you have a database scheme where you work with logically deleted data. So you can, instead of actually deleting data from your database just yet, you have a flag, active, yes, no, deleted, yes, no, this kind of thing. And now, in your snapshot, you only would like to export the data which hasn't been logically deleted yet. So using this select statement overrides option, you could specify specific statements or where clauses for specific tables. So you then could, for instance, exclude those logically deleted records from a table as it's being snapshotted. And the last thing, this is pretty new. I don't know, Chris, since 2.2 or something like, there's this option for parallelizing initial snapshots. So you could have multiple threads and they would work on multiple tables so as to speed up things. So I guess that's not that widely known yet. Definitely worth trying out because it can give a nice boost to the performance of your initial snapshots. Okay, so as I mentioned, this notion of initial snapshotting, this has been part of Debezium pretty much from the get-go. All the connectors really support it. And I would say it worked reasonably well. And still, coming back to the picture I had in the beginning, people have or had some questions around that. So for instance, how can I go about updating my filter list? So this is where I specify which tables I'm interested in capturing from my database. Now, well, if a new table gets created in the database, that's pretty simple. I just can add it to the filter expressions, and by definition, this table doesn't have any data yet, and I would start to capture all the inserts from the transaction log, so that's fine. But what happens if I have an existing table, and this has not been configured to be captured before? I'm just changing my mind. So I'm saying before I wanted to capture those 10 out of my 100 tables in my database. Now there's this 11th table which I also would like to capture. Well, now I can update the filter expression to say, okay, also this table name should be included, but then I lacked the option for getting a snapshot of this table contents. And this can or cannot be a problem, right? And then people used to work around it. For instance, one option would be to set up a new connector instance which just captures the changes for this 11th table. And when this is done, then you would stop this connector and start to, with the other existing connector to continue to read the log. But it's all quite, I would say, cumbersome, error-prone. You would have to think about how do you make sure the cutover is perfect. So not ideal. I would say there was not a really good answer to that. So that's problem number one. Next problem. Well, those snapshots, they can take a long time. So if you have millions of rows or tens or hundreds of millions of rows in your tables, scanning the tables, it can take many hours in some cases. And those snapshots, they were atomic units. So either they completed or they would have to restart it completely from the beginning. Now, this means what could happen is maybe you just wanted to change the configuration of a connector, or there was a rebalance going on in your connect cluster, or maybe your connect worker node just died, and maybe it already had done 95% of this initial snapshot. The connector would restart from the offsets. It would see, okay, I'm currently doing a snapshot, but then there was no way for it to continue and just do those last remaining 5%. It would have to do the entire thing again. So that's pretty frustrating. And maybe sometimes you just want to pause a snapshot. I don't know, maybe there's extraordinarily much load coming to your database and you don't want to have this snapshot procedure going on right now. So you would like to pause it and then later on continue with it. So again, this is something which you couldn't do. Problem number 3, you couldn't start to string changes from the transaction log while this snapshot is running. And now, why could this be a problem? Well, sometimes it's not a problem, but it can be a problem if you care about the size which your transaction log requires on the disk of the database. Because while the snapshot is running, we already, in case of Postgres, for instance, allocated this replication slot. But we are not yet consuming from it. So this means the database cannot get rid of the contents of this transaction log until, as long as the snapshot is running. And this means, I would eat up more and more disk space while my snapshot is running. So again, not desirable. And finally, problem number 4, well, we couldn't really re-snapshot selected tables. So maybe you have put the data into Kafka, and then, I don't know, you had the retention of your topic wrong, whatever, or maybe you just want to push data to another sync system again, and you don't have the complete picture of the data in your Kafka topic. So you just would like to rebootstrap one particular table, and again, there was no good solution for that with the classic snapshotting. So this all leads to, where there's problems, we need to have a solution, right? And this is exactly where this notion of incremental snapshotting comes into the picture. So this is based on a paper which was shared by the engineering team from Netflix, and now I'm guaranteed to pronounce their names wrong, but let me say it was Andreas and Ioannis from Netflix, so I'm dodging the last name, and they came up with their own CDC framework which they developed at Netflix. At some point they wanted to open source it, but it never really happened, so I'm not aware that it has been open sourced, but it is used within Netflix. But what they did is they published a paper called dblog, a watermark-based change data capture framework, which describes their innovative and really cool snapshotting algorithm. So kudos to the Netflix guys for publishing this work and allowing or providing folks like the Debezium team, but also other teams, by the way, to implement snapshotting logic based on that algorithm. And the key idea which they came up with, and it's kind of ingenious, I would say, is to essentially run snapshotting in incremental phases, and we will see what that means, concurrently with reading the transaction log and then putting some sort of deduplication into place to make sure that there's some specific consistency guarantees. So that's the high-level idea, and we will dive a little bit into the details now. So what it is about. So as I mentioned, this happens at the same time. So we have our transaction log, we read from that, and now at the same time we run our snapshotting logic, but now this happens in chunks. So instead of having a single select for a table, which then runs for hours to stream this entire result set, here we run through this table in chunks. So in this case, it's about the customer table, and we get 1,000 records for each execution. And it's ordered. So in the first one, we get like all customers between ID 1 and like 1,000. And then we get whatever from 1,001 to 2,000 and so on. So we get the customer records in those batches of 1,000. And again, this happens while the connector reads from the transaction log. Now, of course, the question is, how can we correlate the data? Because what, of course, must not happen is we read from the transaction log, we do this select at the same time, that we somehow propagate or expose old invalid state, right? So essentially what's in the transaction log, this is the reality coming from the database. So we must make sure that we don't overwrite this with any data which we select concurrently using the snapshotting. And now the idea there is, for correlating this, watermark events are inserted into the transaction log itself. So what happens if I have one of those chunks? At first, there's an insert record written into a specific table in the database. Then the chunk select is executed, so we get 1,000 of our customer records. And then another record is inserted into this signaling table. And now I will see those events which I write, I will see them in the transaction log as well, because I get everything from there, right? So now if we look at one of those chunks a little bit closer, so this is what I would see. I would see this low watermark, which was inserted first, then any random number of events written by applications writing to this database, and then I would see my high watermark inserted and written by the connector. So that's what I get from the transaction log, and at the same time, I get the contents of the snapshot select, so those read events. Now, what I need to make sure is I need to essentially give precedence to everything which I get from the transaction log. So under the hood, the connector reads the events from the transaction log from this window into a buffer, and it then essentially makes sure that everything which shows up in the transaction log, this is giving precedence over everything which is received from this snapshot select. So in this case, there's this read event for key number 1, so which we get from the snapshot. We don't expose this or we don't propagate this because there's actually a delete for key number 1 within the transaction log itself. Same for key number 2, there's an update at the very first position in this chunk window. Now for the record number with key number 3, well, we take that from the snapshot chunk because there's no change to that key within this window. And so we continue, key number 4, there's an update, 5 and 6, they are not modified in this chunk, so we take them from the snapshot select, and finally key number 7, there's an update, so this is propagated from the transaction log. So essentially on a high level notion, what happens is we step in chunks through our database, but for every record which is modified simultaneously, we actually take this one from the transaction log. So that's the high level intuition. Now, what's important to understand is that there are specific changes to the semantics of such a snapshot. So for instance, you won't have any guarantee that you will see a snapshot record or a snapshot event for each and every of your records, because if we go back to the previous slide, you will see if data is modified, well, we take the update or insert or delete events from there. So, we won't have read events for everything. At the same time, what could happen is if we get an update or delete, we will propagate this from the transaction log. and we wouldn't have a snapshot event for that. So that's something which could happen. Or we also, if we could actually have received both events at the same time, because we do this in chunks. So what could happen is I do an update to one particular record in like chunk 1. So we propagate this update from the transaction log, but then this record actually gets re-snapshotted in a future chunk. So we would first get this update, and then we would get this select event. So this all is to say there are some changes to the semantics, but there's one thing which is guaranteed, and this is once this snapshot has been completed, we will have a complete view of our data either in Kafka or within our sink systems, like a data warehouse, cache, and so on. So typically what you just would do is you would apply absurd semantics there. So if you get a record and you want to propagate it into Apache Pinot, you would either insert it if it doesn't exist there, or you would update it in place if it already existed there. So you just would apply absurd semantics, and then once this snapshot has been completed, you would end up with a complete data view of your data set in this sink system like Pinot. So that's the cool thing. And well, now actually let me try and show a little bit of that in a demo, and I hope it makes things maybe a bit more apparent even. Cool. So let me do this. By the way, how's the font size? Is it all right? Can people read that in the back? It's all right? Cool. OK, so I have Docker Compose here. So I run a few things like Kafka Connect with Debezium, a MySQL database, and Zookeeper. I'm old school, I still have Zookeeper. And I think that's about it. So all this is running there. And now I can actually get a shell in my MySQL database. So let's go there. And now the first thing I want to do is I want to create this what's called a signaling table. So as those snapshots aren't happening at the beginning when the connector gets restarted, but they are happening at runtime arbitrarily, we need a way to tell the connector, OK, please do this snapshot now. So essentially like a command interface to tell the connector to do an incremental snapshot. There's different ways for doing that. One way is by inserting a record into a specific signaling table which the connector consumes, and it receives and executes the commands which we tell it that way. And I'm a bit lazy, so I don't want to type everything there, and it would just take too long. So I'm copying this from my cheat sheet here. So I create this table, Debezium signal. Essentially, it just has a primary key, which is about the ID of the signal. It has this type. So this could be like, that's a kind of signal we want to send, like take a snapshot, pause a snapshot, and so on. And then in the data, that's a payload which is specific to the type. So for the take a snapshot command, this would be a data structure which contains the table names, for instance. So I create the table, and I also I grant insert privileges to the user of my connector because, it needs to write those watermarks, those low and high watermarks, to that same table, so it needs to have insert permissions. OK, so I have that. Now, I can put a connector into place. And now I'm going to use this tool which I mentioned, kcuttle, for that. So let me see, where am I? So here, hold on. So hold on, the wrong window. Tutorial, there you go. And now I want to say, I want to register a connector, right? And for kcuttle, it's a command line tool, so I'm not using the REST API of Kafka Connect. I cannot memorize all the URL path and so on. So instead, I use this neat little tool. It has subcommands for showing me what connectors or which plugins there are. So I can do, and actually let me just quickly get my auto completion there. So completion, there you go. So now I can do kcuttle and, for instance, get plugins. And I should say type source. So I just want to know all the source plugins which exist, and I have pretty much all my Debezium connectors there. OK, so then I could configure connectors, pause them, resume them, and so on. Let's do that. And for now, I want to put a connector into place. So I say kcuttle apply. And by the way, this is modeled after the semantics of kubecttle. So if you use kubecttle, then this will be familiar to you. and I say I want to do my MySQL configuration. So that's the same JSON file I would post to Kafka Connect usually. Now this connector is running, and I can, for instance, say get connectors. Now I see, okay, this inventory connector is running, and I also can do ksqtl describe connector, and it even tab completes the connector name for me. So this, goes and fetches the names which exist. So here I see, okay, this is the configuration. So it's not JSON, it's a bit nicer to read here. And for instance, here now I see, okay, my table include list, it just has this customers table. And there's a few other tables in the same database. And also if I look at my topics there's this customers topic. So let's take a look at the topic there. And for that I'm using kcat, and I'm just taking a look at my customer data which exists there. And pretty much this is now from my initial snapshot. So this is what the traditional snapshotting would do. Now let me go and let me do some changes. And for that I have a script prepared. So this just, every second or so, it inserts some records to my customer table. And here I see, those timestamps change, the ID here changes. So I get the change events for those customers as they are inserted. So this is going smoothly. Now let's say I changed my mind and I also want to capture the changes from the products table. And as you've seen in the connector configuration, this isn't currently being captured. So let me change the table include list there. So I'm going to say I also want to do inventory products. Okay. And so I'm changing this configuration. I need to use ksqtl again to apply it. Register MySQL. Okay. There you go. And now if I do ksqtl get connector, inventory connector, let's do that. Let's see, what did I wrong? Okay, let's take a look at the topics then. List. So I still see, okay, there's just my customers topic and all the other stuff from Kafka Connect. And this is because, exactly the problem which I described in the beginning. We told it, okay, also capture the changes from this products table, but there is no backfill happening yet. So to prove that point, let me just do an insert into my into this products table. And this should now be, retrieved from the transaction log. Hold on. There you go. Okay, so if I do my list again. Okay, so now I also see this products table is there. That's good. And I can take a look now also at the contents there. So let's say, again, Kafka cat. And I see just this single event, right? So no backfill of the data. And how would it? And now, I want to have the backfill for this products table, right? And this is actually where I now do my incremental snapshot. So in order to do that, I send this signal there. So I just specify this insert into the signal table. I give it an ID. I say it should be of type execute snapshot. And here I say, okay, I want to just snapshot my inventory products table. All right. And now if I go back to my kcat view here, I see now I have all those read records. So I have received the backfill for this products table, while at the same time the changes to the customers table, they are still propagated. So as I mentioned, we read from the transaction log and we get this incremental snapshot data at the same time. All right, so much for the demo. Let me go back to my slides and see what else is there. Right, just to dive briefly a little bit into the implementation of this. I mean, this is a stateful operation, right? So we need to memorize how far have we gotten, which is the current chunk we are at, because if we want to restart the connector, we would like to resume, for instance, at this particular chunk select and not at the beginning. And this is exactly where the connector offsets help us. So if you have been operating Kafka Connect, you will know this is essentially where we can store this sort of state information, allowing a connector then to resume its operation from some previous state. And here in this case, I see, okay, there's this incremental snapshot collection stuff. So this tells me, okay, there's this, in this case, a snapshot of the customers table happening. And I also see which primary key I'm at. So this is some sort of hex encoded information or data. And now if I would restart the connector, then it would know, okay, this is the chunk select I would need to continue from. So this solves nicely this pausing and resuming issue. Another notion to consider, well, so this solves all of the or many of those problems, and I will expand a bit on that later on. But when you remember, I granted insert permissions to the connector because it needs to do those low and high watermark inserts into the signaling table, which means our connector needs to have write access to our database. And now, depending on how you look at it, this may not be desirable. Many people typically prefer if connectors like Debezium just have a read-only connection so they cannot mess. I mean, not that they would, but they want to be sure that they cannot mess with the data. And at least for MySQL, there's an interesting approach for read-only incremental snapshotting, which has been contributed by the Shopify team, which are heavy users of Debezium. So the general idea is the same. I do this concurrent operation in those windows, but now instead of inserting those low and high watermarks into the transaction log, we do it here just by looking at the executed transactions in the database. And this, in case of MySQL, requires to enable global transaction IDs. And then if I invoke this show master status command, I get the information about the executed GT ID set. So the set of transactions which have been executed on this particular host. So I've marked it there in red. So this long first part, that's like the ID of this host, but then there's this 1 till 5. So those transactions have been executed here. And we do this once at the beginning. We remember, okay, transactions 1 to 5 have been executed. Then we do our snapshot select. We do again show master status to see now which transactions have been executed. So I have those two watermarks in memory. And as I then receive my change events from the transaction log, they also contain the transaction IDs. So I can do the same sort of correlation. I know when I'm within this particular chunk window, and I can do the same sort of deduplication which we have seen before, but without having to write those watermarks into the transaction log. So that's the one thing which we address here. The other thing is I need to issue this command, do this snapshot. And as you have seen, I also did an insert to my database. And again, maybe that's not something which we just want to have there. And this is why there's essentially a pluggable, extensible mechanism for just having different kinds of signaling mechanisms there. So it could be a database table, as we've seen, but I also could configure a specific Kafka topic where I could send a message to which would say, take a snapshot. I could use JMX. I think those are the built-in options, but I also could provide my own option if I have my own management infrastructure. Maybe I want to have a REST endpoint. I could implement this kind of thing using this plugin API. And just in terms of the data structure there, so we have seen the structure before with ID, type, and value. And here, in this case, well, the type, this is about those kinds of signals I can send, right? And I've shown you this execute snapshot command, but I also could pause and resume a snapshot. So if that's what I want to do, I could stop it. I could have some logging stuff going on. And again, in the value, this would be like specific to the particular type. So in this case, it is about which tables should be part of this snapshot. Okay. Right, and now that's the way how I interact with the connector in a sense. This is what it should do. Of course, I also wanted to tell me, okay, how this is going, right? So there's a counterpart to signaling called notifications, which just gives me some status information about what are those snapshot operations doing. In this case, I configured just a log notification, so I could show you now my logs. It's not so exciting. It would just tell you, okay, I'm doing the snapshot and I've progressed and so on. But again, there's a JMX notification and a few other ones, which you then, I know, maybe you want to send those informations to Datadog or whatever you use, so you could implement that. All right, so let's briefly compare those two snapshotting mechanisms. So first of all, Well, can we update the filter list? Yes, I have shown you how to do this, right? I change my filter configuration, I run an interactive snapshot on incremental snapshot for this newly captured table, and I end up with a backfill of this data. So this works, we have seen it. For pausing and resuming, we haven't seen it, but I have shown you how the connector is managing this state information. There is commands for pausing and resuming, so this also works just nicely. Can I string changes before the snapshot has been completed? Yes, we have seen that, which means our database is free now to discard the transaction log segments, right? So I don't need to be concerned any longer about retaining transaction log data while the snapshot is running, also solved. I mean, it would be kind of a surprise, right? If it wouldn't be that way. And finally, can I re-snapshot selected tables? Yes, I can do that because, well, I can, execute this kind of snapshot anytime and then re-bootstrap this products table. Just could insert another of those command records if I just wanted to backfill this particular table. So pretty much all those concerns which we had before, they have been addressed. Happy guy. All right, so finally, we're on the home stretch, a few resources. So there's 2 blog posts by my former colleague, Jirgi, about the incremental snapshotting. There is another very nice blog post by Kate Galieva from Shopify about the read-only implementation, which actually is a bit more involved than I was able to describe. So go and read this blog post by Kate. And as I mentioned, well, the Netflix guys, they made available this research paper, and thankfully we in the Debezium community were able to base our implementation of snapshotting based on this paper. But there's other implementations. So for instance, the Apache Flink CDC team, they also implemented incremental snapshotting based on the exact same algorithm as part of the Flink CDC connector. So in case folks who are using Flink, Flink CDC essentially embeds CDC connectors like Debezium into Flink, so you also would have that option. Finally, a few, advertisements, I guess. So I'm gonna do another session tomorrow with my friend Chris down there, Chris Cranford and Chris Edgerton, so 2 Chris's, and we will do a meet and greet or ask the experts. Don't like saying that. Let's say it's a meet and greet, and you can bring your questions for Debezium and Kafka Connect. So this is going to happen tomorrow at 2:30, I believe, somewhere in the expo area. And also, if you would like to know more about change stream processing with Debezium, which I touched on today, and Apache Flink, so you can do all kinds of stateful operations on your change event streams, like joining the data from multiple change event streams, aggregating them, processing them in any way with Flink. We will do a meetup session at the Dremio office in San Jose tomorrow evening, so you're very much invited to join for that. And I think that's it, yes. So we have 2 minutes for questions. There is this QR code. Now this is where I do my commercial plugs, so this will take us to the Decodable website. It will tell you, what we do. You can come by our booth and get those amazing acorns, so definitely check that out. And it also has all the information about the meetup, so you don't have to memorize the URL. Just scan the QR code. Let me know how it works actually, and it will tell you how to find the meetup. And with that, we have 2 minutes for questions.